Okay, the time has come. I'm going to take a crack at getting the IF alignment on the Philco Predicta Tandem here done. Or at least cleaned up a little bit. For reference, after I reinstalled the IF board and verified that we still got a video signal, I then had to replace the 5AQ5 audio output tube, this little booger right here. It actually had an internal short. I haven't checked the old one out, but I would suspect possibly a heater to cathode short, because on warm-up you would get a little bit of arcing noise in the speaker, and the screen would, you would get flickering bars in it. And it actually burnt out the 330 ohm 1 watt cathode resistor in the 5AQ5's cathode circuit. So I looked at both the output transformer of the circuit and the tube itself. Initially thought it was the primary having shorted turns. I checked that with my my flyback transformer yoke tester that my buddy gave me. Super handy. This, however, did not discover any shorted turns. So I looked back to the tube, found a new old stock one. By the way, Larry, if you're watching, all those tubes he gave me, I got desperate and looked through them, and I found a new old stock 5AQ5 because I had absolutely none in my own collection. So you saved the day there. So that's working. Volume's still not as high as I would want it, but I haven't completely gone through the FM audio circuit. There's a wave trap after the video signal to pick up the sound signal that I haven't fiddled with, and I need to go through all the steps. But first, I want to take care of the video, because the level of detail we've got is not very good. We've got horizontal smearing, and I don't have my fancy new Philips video generator yet, but I'm pretty sure if we were to put up the frequency bars on here, the resolution would be pretty crappy towards the fine side of the scale. Hopefully that'll be here Wednesday, and I'll actually be able to take a look at how good the picture is. But we need to take a look at the setup we've got going. I think I mentioned in my shop update, I've got some borrowed equipment. WaveTech 1801B sweep generator. The output on this is much, much higher than the TV actually needs. It can go up to, what is that, 950 megahertz, which is a bit high, and yeah, I wind up using it pretty low. It's just that right now what we're doing, and what the SAMs and the Philco instructions say to do, is we're actually sweeping through the antenna terminals, through the tuner, and then checking the detected output after the IF stages. Because this is an inter-carrier system, sound and video go together and get split up at the very end. So it's got to be kind of wide in order to grab all of that. And I've actually got the scope over there in XY mode. We're taking a look at the sweep. The pattern is upside down. Sadly, my scope does not have, it's too old, doesn't have the ability to invert the trace to make it look more like the drawing, so I just have to pretend. I've got the sweep width cranked down on this, and I'll show you how I'm going to get that aligned, because the 1801B, at least if yours has the option installed, has some preset markers that are based on harmonics. So this one has 1 megahertz, 10 megahertz, or well, 1, 10, and 50. Well, yeah, they are 1, 10, and 50 megahertz harmonics. So right now I have a marker set at about 69 megahertz, and we're going to use that to center the trace because channel 4 is centered around 69. We want about a 10 megahertz sweep width, so I need to get 5 pips on either side of center, and that's actually pretty easy to do with this. Now sadly, the unit that I bought, my 1801B, does not have those modules installed, and they are not easy to find. So when I do it with my own equipment, I'm going to have to use a separate marker and just kind of do them all one by one. Now I do have both the scope and the generators set to use the line frequency as a reference, so they're stable. You don't have to do that. I could set this one to a variable sweep rate and then have that one locked to the channel, but setting them to line is just easier because it's nice and solid. We are clamping the automatic gain control with a 4.5 volt negative signal from my L&Co variable power supply up on top of the oscilloscope there. And yeah, brightness is cranked down. And I'm going to put you guys in front of the oscilloscope, and we're going to see what the issue is. Now, I have already gone through the basic procedure and peaked everything per the instructions. The fine-tuning is set at a null point. Now what I need to do is correct the irregularities in the waveform because it's got some issues. Okay, so there's our waveform, and as I've left this to warm up for about 20 minutes or so, and as it warms up, the trace kind of drifts off. So first off, I've got a 69 megahertz marker, and I'm going to make it bigger for you. Okay, that's centered around 69 megahertz, so that blob, I can make it wider too. That right there, that's our center. That's our 69 megahertz marker, and I'm going to turn that down. And we want that to be about the middle of the trace. And then I'm going to add some 1 megahertz harmonics to it to make sure we have enough width. Okay. And I'll move this down because the lighting's not great. So we've got 1, 2, 3, 4, and just on the edges 5, so total of 5 on either side, and they're lining up with the graticals, so we know we have 1 megahertz, or 1 megahertz divisions. So that's cool. Turn that off because we don't need it. And what I want to see, I probably should have prefaced this, our goal, I'm sorry to do this to you, our goal is to get that waveform to look a little more like this one. Just imagine that this is inverted. So on the left side, the 42.7 megahertz marker is supposed to be our video carrier. Oh wait, no, I'm sorry. The 45... Is it the 45.75 is supposed to be the video carrier? Okay, well now I've thrown myself off. Either way, there's some markers that are relevant. Let me fire up what's supposed to be... Let's see, 45.75. I thought I had these all written down originally. And I was pretty sure the video carrier was, yeah, video carrier is 67.25, sound is 71.75. Well, let's look at where 67.25 is. So I'm going to set my generator for 67.25 megahertz. Now, it should... Okay, there we go. So yes, that is the video carrier. So the waveform over here, this is our high frequency side, this is our low frequency side. I know that doesn't make a whole lot of sense right now because I just said the middle is 69 and that is 67.25. That's because we're going through the tuner and I'm using post-marker injection. When the instructions were written, they were assuming you were going to couple the markers in with the sweep signal, and the tuner would have converted them into the IF frequencies, so you would input, in this case, 45.75 megahertz for the IF frequency. The tuner would couple it with the local oscillator, and then it would be spat back out as the appropriate 45.75, and it would show up over here. However, doing that, the markers are a mess. They are hard to see, and they screw with the waveform, and they make it a pain to work with. However, with post-marker injection, you get this lovely teeny tiny blip right here. They call it a birdie, apparently. And that makes it much easier to work at, but because we're bypassing the tuner, it doesn't get converted into the appropriate signal, so I can't put in 45.75 and have it show up on this trace. It wouldn't appear at all. Thankfully, Bob Anderson provided me with a picture of an original Philco 903738 datasheet, which included a figure that shows the response curve for channel 4 with both the IF frequencies and the RF tuner frequencies overlaid. So I have a cheat sheet with all the relevant frequencies. So the 45.75 megahertz marker is actually 67.25 megahertz for the channel 4 tuner, and that's what we're looking at over here. Now the problem is, according to the datasheet, the 67.25 marker is supposed to be our video carrier. That should be halfway up the total amplitude of this signal. So that should be, well, closer to this middle gradical right here, and it is not. For reference, on the opposite side, we have the 42.7 megahertz marker, which we have to convert to 70.3 megahertz for channel 4. And that one's going to be a little more difficult to see because it's on a steep slope and it doesn't show up so well, so I'll make it really fat for you. It's, well, actually, it's right about there, about halfway up. That one is supposed to be a little higher, about 60% up the waveform is what they say it should be. But the fact that that is higher than that one tells us there's a bit of an issue. Other relevant frequency is going to be 45 megahertz, which we need to set to 68 for the tuner, which is over here. That one is just... Ooh, I don't know why I just did that. That one is just below what should be the other peak. So it should be a double hump. That should be the middle of the double hump, and we just kind of have a lopsided shape right there. So that's kind of where it should be. But the top of our response curve is all jacked up. And then lastly, we have the 43.85 megahertz marker, which I need to set for 69.15 megahertz. Okay, that one should pop up, yeah, somewhere around here. It should actually, yeah, so it needs to be closer to that side. So it's not supposed to be in the middle, it's supposed to be just off-center of the middle, per the drawing. So that one's probably where it should be. I'm going to recheck the 69 megahertz reference, because this thing does like to move around a little bit. Holy crap, this took a lot of fiddle farting around to accomplish, but I'm pretty confident that I've got the response the way I want it. Alright, let's see if I can get the graticals on there for you. Okay. First, and I see the problem is you can't really see the image. Whatever. Anyway, currently we're sweeping through channel 4. Tuning has been set the way they want it to, etc., etc. Anyway, I fought for a while to get the markers on either side of the waveform to be where they should be. One should be about 50% of total amplitude, the other should be about 60% of total amplitude, and they were wildly off. I thought maybe there was an issue with the tuner, but bypassing the tuner showed that in reality the issue was... It wasn't the tuner, it was in the IF strip itself. So I played around with the slugs a little more. What I found was I wasn't making use of one of the tuned coils and a little further up in the head end, which is A4 in the SAMs. It's a flathead screw slug. So it turns out if I used that to adjust the low side, everything kind of plays with the other parts. So you kind of have to go around in circles until it gets pretty close. Anyway, so I mathed some of this out because it's 1, 2, 3, about 3.5 graduations. I got the other points pretty damn close. They're not perfect, but they are damn close. So first and foremost, that birdie right there, it's in the center, or just a little off of center, more specifically. There's a dip in the middle. That is our 43.85 megahertz marker. Now if we check the 45 megahertz marker, whoops, sorry, I say 45, but I have to remember this is set up to go through the tuners, so I have to put in 68 megahertz. Alright, where are you? Alright, right there, just around the bend and on the edge. So that's the 45 megahertz marker, that's about where it should be. Now let's go check the 45.75 megahertz marker, which should be the start of the video carrier, which was 67.25 here. Now, as you can see, it's popping up right about there. So that's about right. It should be about 1 3/4 graduations. It might be a little under that, but it's as close as I can reasonably get it. And now its friend on the opposite side, the 42.7 megahertz marker, we input 70.3. We can see it pops up over here. And that's at about 1, 2, maybe 2.1. And let me just verify that on my calculator. So if our overall is 3.5, we want 60% of that. About 2.1-ish, so just a little over 2 graduations. So, I think we are reasonably good. At least I'm pretty happy with it. Honestly, I won't know how well it really works until we start throwing signals through it. But I call this a win. And I think we should try hooking up the DVD player and see what we get. And I should also try hooking the component or the composite output of the player back through just to compare. But we'll see. Okay, so this is kind of neat. I just switched off the sweep generator, a whole bunch of other stuff, turned off the clamping on the AGC and all that good stuff. What's funny is I just switched on the modulator. I haven't hooked the antenna up or gotten anywhere near it, and as soon as I did that, it started picking up the signal, and again, this is all subjective, but it does look better, and that's from a very, very weak signal that it is pulling in pretty nicely. So I'm going to grab the antenna and actually bring it up towards the set. I'll be honest, that does kind of look nicer. What I need to do is get this back to the main menu because that's where the smearing horizontally was most apparent. However, I'm not seeing stuff around like the brims of their hats. It's not stretched out and wacky. Okay, he's got tassels on his elbows. That's what I'm seeing there. Okay, I'm gonna have to hit stop on the DVD player, but that doesn't look bad. Honestly, that how much volume do I have? Background hums in there. Also, it looks like we've got a little bit of black at the bottom, so I'll need to adjust that. And contrast control. Alright, let me hit stop if I can see the buttons. Plastic cables are caught under and over and underneath everything else here. This is how you want your lab set up, obviously, is with all the equipment on the floor where you can step on it. Alright, so if I hit stop, press play to play from here, plus play and play from the beginning. Okay, so we gotta hit stop again. And then we gotta hit play again, and that should reboot us to the main menu. Okay, so I'm not... there might be a little bit, but I'm not seeing a whole lot of stretching around, because mostly where I was noticing the smearing was in the words. Okay, there might be a little bit still in there. But when we get to the main menu, it was very apparent around the main selections. But like I said, I have a signal generator showing up. There's a very specific spot where the audio comes in nicely there. Okay, I mean, I'm not seeing anything around the Lone Ranger here. It's kind of difficult because the Ranger here, his code is about the same color as the words. But I mean, it doesn't look that bad. And, I mean, it's a pretty big picture, too, but everything in here, the brim of his hat, all that seems to be fairly... Autoplay. Seems to be fairly well defined. At least to me. Crank up the contrast.
Dust and a hearty hi-yo silver, the Lone Ranger. This is a story of one of the most mysterious characters
okay, in the early days of the West. Episode 1 for the 50th time. Oh, oops, I get junk on there. Not bad. honestly. However, I will need to take a photo. I do have some references from the other adjustments I have made to the focus and everything. But overall, it doesn't look that bad. Although I do notice we either have a height or position deal needs to be corrected. There's black down here, so we gotta get rid of that. Might have to either bring the height up or change it. Linearity doesn't look bad, but again, on Wednesday I should have my brand new generator, and assuming that it doesn't get kicked off of the truck, I'm hoping it should work pretty well. It's a microprocessor-based unit. Honestly, that Texas Ranger badge did look like it was a little crushed on the bottom, so I imagine that the height and vertical linearity needs a little bit of touching up. But honestly, I'm kind of happy with the results. And of course, I still got to go through the sound system, but the sound system will be absolute cake compared to doing the IF. But yeah, this is just loose coupling through. And if I change this to local, that's distant. And it doesn't look bad. At least I don't think it does. And we don't have any artifacting in the video. There's no pops or clicks or anything from stuff arcing. And yeah, okay. I don't know if I want to keep on going and do the audio here too. I might. So I've already got the set warmed up. Yeah, I might do that. I think I'll get this thing set up and we'll try scoping out the audio section. Okay, while going through the sound adjustment instructions, I realized I made a bit of a goof. I started tweaking the points they said without realizing that I was supposed to have a special detector hooked up in order to capture the 4.5 megahertz carrier. Because otherwise it'll get coupled into the cathode circuit of the picture tube, and the sound will actually show up on the screen, and I've kind of got that going on, so I need to readjust it correctly. The trouble is, you need to make, or find an original, this little circuit right here. So we have a tank circuit here, coupling capacitor, a germanium diode, and then a connection for a vacuum tube voltmeter. This gets hooked up to the cathode circuit of the 21 EAP4 or whatever, and we have a wave trap. It's a center tap transformer, and that is A10 on the SAMs, and that is this little booger right here, and this core gets adjusted to keep the audio signal out. Now, at first I thought that was adjusted to actually improve the signal strength of the 4.5 megahertz signal going into the audio section. No, it is purely to keep the audio signal from making its way to the video circuits. And I have misadjusted that because I didn't do exactly what they said. Didn't read through and read ahead like I should have. So now I need to fix it. Now, of course, the instructions detail the use of a Philco specific part number or equivalent, they say, this little tune circuit here. It's supposed to be peaked to 4.5 megahertz, and I thought, well, shoot, I don't exactly have that sort of thing laying around, except I did have a whole box of tunable coils. I bought a bunch of surplus TV parts from a recycler, actually. I guess someone dumped off a giant cardboard box full of coils and transformers and all sorts of random stuff, and in them I had a whole bunch of these tunable slugs. You can actually see the voltmeter reacting to my finger. Unfortunately, it's not shielded, so if you get too close to it, you do affect the center frequency that it likes to resonate at. Right now, though, I have it set. There's a got the signal generator hooked up to the input, and it is providing a 4.5 megahertz signal at, I got the amplitude set, 1 volt peak to peak. And the output is being connected directly to my Heathkit vacuum tube voltmeter, and it's showing just about in the middle of the scale there. And I can show you, if I adjust the frequency by 1/10 of a megahertz, if I go down to 4.4, our amplitude drops sharply, and if I go back up to 4.5, Now if we go up to 4.6, drop sharply, and I think about the same amount. Not quite the same amount, but pretty darn close. And then if I keep scaling it up, 4.95, whatever, it continues to drop. So overall, now this is where it's peaking. I tweaked it using a ceramic, these cheap ceramic screwdrivers. I really don't like these. I bought them off of Amazon a while ago thinking I could use them to tune stuff. They are probably meant for like variable resistors and modern things on circuit boards instead of what I'm trying to do. I have the correct tool to adjust this. Oh, you know what? That might be upstairs. That's why. I have it with the Sylvania television. I couldn't find it down here. That's the last place I used it because the width coil is one of those tuned slugs. Anyway, this particular slug had about 25 microhenries in the center of its range, and I paired that with a 68 picofarad capacitor because initially I noodled it out to be about 47 picofarads would work to get 4.5 megahertz. I didn't take into account all the additional lead length and everything, and it made it so that it wanted to peak closer to 4.6. So I bumped up the size of the capacitor to slow it down, and that allows me to get an adjustment just about in the center of travel where it actually peaks at 4.5. The only thing that I was having trouble with, though, was the detector diode, which originally was a germanium 1N60, which I think it was meant to replace the 1N34, which was used as the video detector on some sets. The Sylvania actually uses a 1N34 detector diode, as well as my GE portable television. I believe used a solid-state detector diode, kind of a cartridge fuse type. Anyway, I checked around and I didn't have any germanium diodes. None of my parts bins. I swore I had a small container of very early germanium diodes, but I haven't been able to locate it. So instead, I dug through my collection of old Radio Shack and Archer parts, and buried deep in the bowels of that, I found this original ECG 109 germanium diode that is specifically for AM detection, automatic gain control, and video detectors. 46 cents new from Empire Electronics. No idea where that was. So that was handy. The only one I had, and it works. I have the little glass body guy right there. Works out just fine. And we are going to put this to the test and see if I can't eliminate the video bars. Okay, so earlier I constructed this 4.5 megahertz detector circuit based on Philco and Sam's little schematic, put it together with some scrap parts I had lying around and an original germanium diode. And I got it to work with my vacuum tube voltmeter and the signal generator, but I could not get it to pick up a signal when connected to the cathode circuit of the CRT through the big socket here. That's how they said to do it. Could not get it to work. Talked with the guys on ARF, and they suggested trying it in different spots. Maybe try it in the grid circuit of the CRT instead, which would be coming off the plate of the 6AW8 video amplifier tube right there. There's actually two video amplifier tubes. There's that one, and then there's the 3CB6 inside the screen housing itself, but I wasn't going to go all the way in there and dig around. Instead, there's a grid connection on the plug here, actually, pin number 1, which is the shielded in the cable anyway, video signal connection. So I tried that, still couldn't get my meter to register anything, and it was really annoying. So I thought, well, maybe the detector circuit doesn't quite work, and so on and so forth. I couldn't quite figure it out. Well, my good friend, Dr. DeSaro, had my Fluke 8021B multimeter in his possession because it had some failed components on it. I haven't been using this for a while because apparently one of the old capacitors on it actually blew and took out part of the circuit board. Caused some damage, wiped out a crystal, and I could no longer do AC measurements, and it was behaving badly. So I gave it to him because he likes to work on test equipment. And he was able to completely clean it, rebuild it, just go above and beyond as usual to make it work nicely. So since I had that back, and I had been banging my head against the wall with getting this to work, I figured I'd drag it out. Well, it turns out there must be something goofy going on with my vacuum tube voltmeter because this absolutely picks up the signal that we're dealing with. So I'll show you what I mean. So if we watch right here, I'm on the 200 millivolt scale. This is not ideal for doing this kind of work, but right now it's the only meter I have that can go that low. At least one that I know for sure works. So I've got the signal generator tuned to 4.5 megahertz with a 400 hertz AM modulation on it at 30%. And we are going to give it a 10 millivolt peak-to-peak output. So we've got not a whole lot of much right now, but if I just nudge this up a bit, there's 20, we're up to 40 millivolts. I can hear it in the we're in 60 now, 70, 80. And if I keep going, you'll see that DC potential goes on. Obviously it's not a lot, but it's there. So we're going to dial this back. We'll leave it at 100 millivolts because that's what the signal generator defaults to typically. And I'm going to try and figure out how I can adjust this without disturbing this part of the circuit. I may need to move it away because if I put my hand in here, because that coil is not shielded, I actually wind up adjusting the circuit with my hand's capacitance. Alright, we want it to be right there. And make sure, well, it looks like I'm still having some small amount of change on it. Make sure we still have a reaction. Yeah, if I turn that up, that goes up. Great. We're going to set it back to 100 millivolts, and I'm just going to move this slug left and right. We're going to go counterclockwise first. So if I go counterclockwise, whoa, look at it go. Yeah. So if I crank this, how close are we to the outside of the coil form? If I go all the way up, that's flush with the top of the coil. I could screw it all the way out if I wanted to. Now if I run this sucker all the way back down into the bottom, which you gotta be careful as it might get stuck. Oh, we just went off scale. Let's back it up a little bit, shall we? Okay, there we go. We're gonna go slow through here. This is where having an analog meter with a needle is so much nicer, but hey, you work with what you've got. Still going down. Nope, and we just started to climb back up there, you see that? Alright, so that means... that's our null. Right about there. Give or take. Obviously, me being close to the circuit is still going to cause a little bit of a fluctuation. The signal is so weak. But now if I turn this off, obviously it'll change a little bit, but it should do what we need it to do. That should have accomplished it. Turn that back on. Let me turn this up. We should see that increase as well. Yes, we do. Now I am going to do one thing. I'm going to go over the frequency and I'm going to off-center it to 4.6 megahertz. 4.4? Yeah, see? At 4.5 we have the lowest potential, and at anything else... interesting. Our sound circuit appears to be peaking at about 4.4 megahertz. Interesting. Yeah. That should take care of that little error. Okay, go back to amplitude. We can turn that down. And there we go. Sound trap is adjusted. That really just leaves the actual sound circuit, which is just tuning a few slugs. That, they do actually specify to just use an ordinary signal coming in. Yeah, tune in a weak station. Adjust for best picture. Do not change setting of fine-tuning. Connect the antenna for a strong signal. Crank up A9 for maximum sound. Use peak for this clockwise. That should be the quadrature coil. And then there's a few other... Let's see. Disconnect antenna. Adjust 10, 11, and 12 for maximum sound. Reconnect it again. You touch A9 for maximum sound. Okay. Well, we'll have to do that next. I have played with that previously, but I might as well do it again just for practice. Okay, so with the 4.5 megahertz trap set up reasonably well, I already went ahead and dealt with getting the audio section tweaked. There was a lot of back and forth in there, so I didn't wind up filming it. Sorry about that. It more or less amounts to hooking up a... disconnecting the antenna from a signal source, tuning the set into that channel so you get the best picture, and then tweaking 4 different audio points in the audio system to get the best, strongest output. And those are, well, first off, this little guy right here. This is the quadrature coil. You would adjust that one for best audio first with the antenna loosely connected, or sorry, the antenna disconnected. Tune in for a good picture. Tweak that for best audio. Then you'd hook the antenna up for a strong signal. Tweak the 4.5 megahertz pickup coil right here at the front. And then you would tweak the 2 slugs. There's an upper and a lower slug inside the ratio. I guess it uses a ratio detector for the FM inside that can there. And then after you've done all of that, you go back to the quad coil and you tweak that again. Now all the other ones peak fairly easily. The quad coil actually has 2 definite peaks in it. One at the bottom of its range and one like 3/4 of the way up. The instructions say to use the one the furthest counterclockwise. So you'll hear one at the lower end, and as you bring it back out, you'll hear it the audio pick up again, and that's where I left it. Now it does get a little bit louder if I screw it out more, but it becomes more buzz than audio. So I tweaked this to get the strongest audio signal from my DVD player rather than just noise. And yeah, it works pretty well. I will say, though, I still don't think it has as much audio output as it should. But again, I don't really have anything to compare it to. Cranked up all the way, it is certainly listenable. And of course, it's outside of the cabinet right now, so I don't know if the cabinet will add to make it a little bit louder or not. And I do have the original speaker hooked up here. The original wiring was shot. The quick disconnect pins on the end were just gone. And it would be handy to have a quick disconnect system so you could take the speaker and leave it in the cabinet. But since this uses, the nuts to remove this are pretty easy to get to, I decided to replace it with some shielded audio wire that I had laying. I think this is actually intercom wire. But I made it a little longer than original so that you can actually pull the chassis out without snagging it on the speaker. And tied the shield to the chassis here. And I think that'll keep it from picking up any noise while it's, the set's nearby. So we'll go ahead and we will take a look at how it works. Oh, 2 other things that I did, mostly just a little bit of housekeeping. Over here, sorry, I actually replaced the original fusible sand resistor with a modern 10 watt, I think 5.6 ohm resistor here and a fuse, and I got some pins to plug it into the socket there. Those pins actually came off of a junk 80 rectifier. The pin size for that right there, I have seen people use Molex pins for these, but these happen to be the same diameter as the, maybe these are the 2 larger pins? I can't remember if these are the larger or the smaller. I think these are the 2 smaller pins from the rectifier. The 2 big ones for the filament, the plate connections are the 2 smaller guys. All I did was, since this one has cracked glass and it's already gone to air, I just took a pair of pliers and I gently worked the pin until it fatigued at the base here and broke, and then desoldered the ends and pulled it out. And then it was pretty easy to fill them full of solder and reuse them. I decided I just didn't want to trust this in the set because these connections are already kind of crap, oxidized, so I'll hang on to that. Might use it, but I have plenty of spares so that I can make more, although I think I'm out of fuse holders. The other thing that I took care of, I replaced the dial lamp in the UHF converter. I know I'm not going to use it, and you can't pick up anything on it, but I wanted the lamp to work that when you switch it to UHF, it would light up. And the tuning knob assembly also has a dial lamp, and it's supposed to have a cardboard sleeve around it, just like the UHF one does, to direct the light towards the channel cutout on the dial here, because these are all perforated and clear on the back, so the light should shine through the number that we want, or mostly. This is just some cardstock that I cut into a rectangle, rolled up like a cigar. And I needed a form that was kind of close to the outside diameter of the bulb holder, rather than the bulb itself on this one. And I found this old capacitor body was exactly the same size as the lamp holder OD, so I just wrapped it around that. And then I used Loctite 495 instant adhesive. And when they say instant, they mean instant. Do not get this on your hands, or it will be there for quite a while. Apparently some people use it for fixing cuts. And I don't know if I'd want to do that myself, but it does work very, very well. And it's just one little touch that I felt was worth putting on there. And that's going to about do it. Sweep alignment and all that good stuff. I did go back and test some of the tubes just to make absolutely sure. Everything else tested good. Obviously replaced the 5AQ5 output tube because that had some shorts in it that was causing problems. So that's fixed. Everything in the RF and IF sections all test good. And it's got a brand new 6AW8 for the video section and everything. So, I don't have the DVD player hooked up. Instead, I have my new toy. My Philips PM5515 pattern generator is down on the floor. And we're going to go ahead and fire this up and take a look at the picture settings. I've already tweaked it a little bit. I'm just going to hit the switch here. And alright, our light's coming through the little cardboard tube nicely. It's shining through 4. I mean, kind of hard to see from this angle, but, yeah. And I have the knobs removed. On these guys here, the knobs have twin pots, inner and an outer. The outer is the standard control. The inner one fiddles with things like height, linearity, and the bottom one is actually part of the horizontal oscillator, which I don't need a screw with. Now right now we're not getting anything because the modulator, the CMOS battery in it is shot, so it is not remembering the frequencies I have set. It's like at 500 megahertz. So we're going to tell it we want channel 4, so that's 69.0. And now we get a signal. I just need to rotate the knob, and what are we on? I think we're on grayscale. Let me just turn this here. There we go. So there's our grayscale. That may actually be color bars, but the PM5515 does have a monochrome setting. You know, I got a pretty decent look there. Now, now I can't see the controls on the front of the unit. One moment. The thing that I was most concerned with was the effective bandwidth of the set, because that's going to tell us how good the image is going to look. Now I will move you closer to the screen so you can get a better idea of that. So there we are, and this is about that's as bright as it'll ever get. So about right there, we can see that very last line over here. And I have already touched the linearity and height and all that good stuff. But let's see, the important one I want to look at is multi-burst, which is, whoops, this one will actually do multiples. I can combine patterns, which is really neat, but if we just do multi-burst, there we go. It's not bad. Obviously, if we off-tune it really, really awfully, we lose some, but I'm not sure what's standard for this set. I don't know how good the response is supposed to be, but I'm quite positive we should be able to see these lines all the way back to this last section here. What this is saying is partly the CRT is tired, but also that we're not getting a lot of the high frequency data again. At least I can't remember if that's supposed to be high or low. I believe this is the low frequency side and this is the high frequency side. I don't know what that was. I can see these bars, I can see those, and those, but the depth of color, or the contrast in them, is supposed to be directly proportional to the amplitude of that frequency, and these are not very bright. And unfortunately, I've already given back all of the sweep equipment that I borrowed from my friend, and this was really the best I could manage with what I had and my understanding. It's the first set I've ever actually properly done a sweep alignment on, and it fought me. So it's not great, but it is watchable. It's good enough. They say perfect is the enemy of good. Obviously, I'm going to keep trying on my own sets to get more experience with it, but it's not great. Anyway. Frequency response aside, we can look at are some of the other things that this generator is capable of. So we've got a circle here. The bottom left looks a little funky. We've got a rectangle. This is the one that's handy for setting the screen size, which I've already done recently. And you can see I've got just the edge of the rectangle there, a little bit at the top. I swear that I had the bottom set a little better than that, but we'll let the set warm up for a while before I tweak any of this again. Probably about a half hour or so to get everything warm, and then I can touch on the video settings. But again, we can combine patterns, so the circle and the rectangle make it really nice to see if things are jacked up, which they very clearly are a little bit stretched down there at the bottom. And what else do we have? Oh yeah, we can also just do a purely white screen if you want. So that'll just test, what is that, purity? Yeah, it's just a pure white screen. We've also got checkerboard. We've got a grid pattern. Very nice. We have dots, which doesn't really work so well on this. Maybe I'm not fully in the monochrome setting. And there's our grayscale. Oh, I must have been looking at color bars before. And then we got this one. This is a VCR setting, which is an interesting deal. I'm not entirely sure what on a VCR it's used for, but there it is. And of course we had color bars. This one is just called, I think it's supposed to be called Demo. That's kind of neat. And then the last one is, well, here's the purity control. So this is supposed to be red, green, and blue for the color sets, and this unit will actually allow you to combine more than one color. I suppose if you're setting up the individual electron guns and doing convergence stuff. I'm not a color TV guy, but that is a neat feature. But this right here is probably the most useful out of all of it. Now, as far as tweaking the size settings and linearity on all that on the set, I'll show you here. I guess I can try to show you. Alright. In order to tweak these, you need to pull the knobs off, and then you need a small flat blade screwdriver. I've got one of these little guys. Don't mess with the bottom one. That's actually part of the horizontal oscillator. I think that's the ringing coil, which on the 17-inch chassis is... I don't remember where that one is. I think that's on the back of the chassis, actually, on the deflection board. On here, it's the inner one, so this guy is the horizontal control. The inside is the ringing coil. The center control, which should be our vertical. Yeah, it's our vertical right there. I gotta remember now. Let's see. The vertical hold... yeah. So the vertical hold shares its control with the height. So the inner one here, this guy, you can watch the screen over there, that one is going to tweak the height. So we can actually bring that in a little bit, and that makes the circle slightly less weird. And then the top one, which is brightness, shares its control with the vertical linearity. So we can do that. And that's about all there is to it. So that's still a little bit too cold. I'll probably let it warm up some more. Make sure everything is still happy. And then we'll put this back in its cabinet and we'll see how it looks. Now I do have the antenna setting back here set to local. If we crank it up to distant, it tends to wash things out a little bit too much amplification since we're doing a direct connection. This thing's going to wind up being hooked up to a modulator for its entire operating careers from now on, so it probably just needs to function well in local. And unfortunately, I do not have an audio source to go through this unit because the input is actually a DIN plug, and I don't have a pinout for it at the moment. But, yeah, it just produces that wonderful noise there when you crank it up. That's interesting. If I turn off the carrier, it shouldn't do that anymore. You can also input an external carrier, apparently. Alright. Here we go. What we can do is, let me see if my modulator is on, which it is not. We can flip over and just see how it sounds. Or at least I would. Let's see. Put that one in over there. Okay. Boot up the VCR. Alright. What's nice though is this thing is actually still picking up. I've got the other end of the cord here. It's strong enough, or at least it has enough amplification. If I do distant, it doesn't make it that much better. That deal is actually putting out a decently strong signal, or this has enough amplification to continue picking it up, which is nice. Now, we're going to swing it over here, and I'm going to turn this off. And we're going to hook it back into the bottom one. I'm going to turn the overhead off.
This is a story of one of the most mysterious characters to appear in the early days of the West. He was a fabulous individual, a man whose presence brought fear.
So that's as much volume as we normally get.
Who wanted to make this frontier land their home. He was known as the Lone Ranger. Before his coming, this new land of the West was a wild, unruly territory.
Now, one thing I will say is I did compare the video to a normal LED television, and the source material is not that great. This is a fairly cheap recording, and a lot of it was washed out. I did try a suggestion using some newer movies, but there seems to be some artifacting that occurs from some of the video information that made it kind of annoying to watch. It did work, but I don't recommend watching The Matrix on one of these. But for period programming,
Right alertly across the western landscape.
should work just fine. What I'm more curious about is I've been watching this on... Okay, well I guess Channel 4 is behaving now.
Suffering from a severe wound.
But on the bright side, we do get static. Or snow. And, plus, it locks in really nicely.
Very few people are after those outlaws who struck.
Curious. Now, honestly, though, the output's not as bad as I thought it would be. Except for the fact that I'm pretty sure I've got the thing set to channel 4 and it would only receive it on channel 3. Which is kind of weird. Yeah, I very clearly have it. Yeah, I think this modulator's kind of meh.
There. Only a short distance farther.
But hey, it works. We don't get sound bars. My plan is actually to give a modulator to the owner of this set to keep with it when he decides to part with it. As if it works with it, I mean, hey, might as well. And I've got like a pile of the things that I kind of don't need. It is watchable and it is listenable, which are the most important things here.
I still mean not hurt you.
Well, I have to wait for the producers to put it in focus first.
Why, you Kemo-sabe. Kemo-sabe. That sounds familiar.
Well, I think that's pretty good anyway. Oh, one little thing I forgot to mention on the size controls of the three connections, or the three controls that are over here. So, brightness and vertical linearity, vertical hold and height, and then horizontal hold and the ringing coil. You might notice that there's no width adjustment over here. That's because the width control, at least on this chassis, and it might also be on the Holidays for all I know, is right here. It's hiding around the corner just behind the local distance switch. That is your width control pot. And it's got a rather beefy power resistor coming off, and I think this is a wire wound. Seems it's got a decent amount of current flowing through it. And mine is still good. Or this one's still good anyway. But, yeah. I'd say so far so good. Anyway, I think it's going to do it for this video. I'm reasonably happy with the results I'm getting. I've learned a lot working on this set, but I obviously have a long way to go with understanding doing IF alignment sweeps, sweep alignments on these TVs. It's kind of a new field for me, but I have been acquiring the equipment to do so. I just need to get it in good working shape before I can trust it. And yeah, next thing to do, I suppose, is going to be to package this back up and into its housing, clean it all up a little bit, and then give it a crack outside of the shop here. So until then, thanks for watching, and I'm going to have some stuff about the 1930 Franklin coming up here soon. I'm trying to get that in good shape before the weather gets really, really nice, because I'd like to take it out and drive if possible.